Have you ever looked at a fish swimming effortlessly through the water and wondered, can it actually drown? It sounds like one of those questions with an obvious answer. After all, fish live in water. Asking if they can drown seems almost as strange as asking if humans can suffocate while breathing air. But nature is rarely that simple. Fish depend on water to breathe. Yet under certain conditions, the very environment they rely on can become deadly. Some fish can survive out of water for hours, while others may suffocate in water that looks perfectly clean. And believe it or not, some fish really can drown. So how is that possible? What does drowning even mean for an animal that spends its entire life underwater? Today, we're diving into the fascinating science behind fish breathing, the surprising situations that can cause them to drown, and why the answer isn't as straightforward as you might think. Right here, on History of Simple Things. To understand whether fish can drown, we first need to know how they breathe. Unlike humans, fish don't have lungs. Instead, most fish use specialized organs called gills. As a fish swims, it draws water into its mouth and forces it across thin structures inside the gills. These structures are packed with tiny blood vessels that absorb dissolved oxygen from the water while releasing carbon dioxide. Although water contains far less oxygen than air, fish have evolved incredibly efficient gills that can extract what they need. In fact, some fish can remove over 80% of the available oxygen from the water passing through their gills. This process only works because oxygen is dissolved in water. Fish aren't breathing water itself, they're breathing the oxygen that's mixed into it. That difference is the key to answering today's question. So, can fish actually drown? The short answer is yes, but not in the same way humans do. When we think of drowning, we usually imagine water filling the lungs and preventing oxygen from entering the bloodstream. Fish don't have lungs, so that can't happen. Instead, a fish drowns when its gills can't get enough oxygen from the surrounding water. If there's too little dissolved oxygen, the fish essentially suffocates, even though it's completely submerged. Scientists often describe this as suffocation rather than drowning. But in everyday language, many people simply say the fish drowned because it died from a lack of oxygen while underwater. So while the mechanism is different, the outcome is remarkably similar. It's easy to assume that all water contains plenty of oxygen, but that's far from true. The amount of dissolved oxygen changes constantly depending on temperature, movement, and the organisms living in the water. Cold water holds much more oxygen than warm water. Fast-moving rivers and ocean waves continuously mix air into the water, increasing oxygen levels. Calm ponds, especially during hot summer days, often contain much less. Plants also play an important role. During the day, aquatic plants produce oxygen through photosynthesis. But at night, they stop producing oxygen and begin consuming it, just like animals do. If oxygen levels drop too low, fish begin to struggle. They may swim near the surface, gasp for air, or gather where waterfalls and currents provide fresher, oxygen-rich water. If conditions don't improve, they can suffocate. This is one reason aquarium owners need filters and air pumps. In a closed tank, fish continuously use oxygen while releasing carbon dioxide. Without water circulation or aeration, oxygen levels gradually fall. Overcrowding makes the problem even worse. More fish means greater oxygen demand, while excess waste encourages bacteria that consume even more oxygen. That's why fish can sometimes die overnight in an aquarium if equipment fails or the tank is too heavily stocked. Ironically, they die surrounded by water. Here's one of the strangest situations where a fish can actually drown. Many fish rely on constantly moving forward so water naturally flows through their mouths and across their gills. Species like tuna and some sharks depend almost entirely on this continuous movement, a method called ram ventilation. If these fish are forced to swim backward or are dragged backward too quickly by fishing gear, the normal flow of water across their gills is disrupted. Without enough oxygen reaching the gills, they can suffocate even though they're still underwater. Fortunately, many other fish can actively pump water over their gills using muscles in their mouths, allowing them to breathe even while staying still. Not every fish depends entirely on gills. Several species have evolved the ability to breathe air directly. Lungfish possess true lungs and regularly swim to the surface for air. Betta fish and gouramis have a specialized organ called the labyrinth organ that lets them absorb oxygen from the atmosphere. Some catfish, mud skippers, and climbing perch can even survive outside water for surprisingly long periods if their bodies remain moist. Ironically, these fish may actually drown if they're prevented from reaching the surface to breathe. In other words, an air-breathing fish can suffocate underwater. Nature loves exceptions. The answer is yes, but with an important distinction. Fish don't drown because water enters their lungs. They drown because their gills fail to obtain enough oxygen from the water around them. Whether it's oxygen-poor water, failed aquarium equipment, being pulled backward, or an inability to move water across their gills, the end result is the same. Their bodies simply can't get the oxygen they need. It's a fascinating reminder that breathing isn't about air or water alone. It's about oxygen, and every animal has evolved its own remarkable way of finding it. The next time someone asks whether fish can drown, you'll know the answer is much more interesting than a simple yes or no. And sometimes, even the place where an animal is supposed to be safest can become the very thing that threatens its survival. Thanks for watching, and I'll see you in the next episode of History of Simple Things. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.